Hello everyone, welcome to part 3 of the recitation serial debugging. In this recitation, we will be talking about three types of errors, which is the coding error, the time errors, as well as the time issue that you might face while training, and the memory issue. In terms of coding errors, there are three basic errors that we will be covering, such as syntax errors, logical mathematical errors, and runtime errors. Finally, in the memory issue, we're going to be talking about how to deal when you see this common problem of CUDA out of memory and when you see that some of the variables are not on the device and how to handle them. For syntax errors, even RSTAs mostly use Stack Overflow, and they are the best source for searching this. As we'll see in the demo later, you can see that if there is a syntax error, uh, Collab will directly give you a link to Stack Overflow, which you can use. And referring to the Recitation 0A of Python and OOP fundamentals is also imperative because that goes over a lot of the programming aspects that are required for this course. In terms of logical and mathematical errors, as you will see in homework part ones, there will be a lot of matrix multiplication and mathematics that is involved. The best way to understand and implement this code is to read the write-up and write it down first and then implement it. Particularly in homework 3P1, when you're coding the backward of the functions, it becomes imperative to draw the diagrams and go from there. Checking the shapes of the variables is when the matrix multiplication errors happen, you print the variables shapes to figure out what dimension might be going wrong because that is the most common source. Reading the NumPy documentation helped me personally a lot. And for its purpose, the figuring out what input it expects, the type and the shape, and as well as the output type and the shape. In terms of runtime errors, you should look at the traceback to find the root of the error, and the library documentation helps you understand what format do the input arguments require and the output format. Settings, sometimes you might not be able to see the error on GPU when you might be getting an error such as device side error asserted. In that case, set the batch size to 1 and run the code on CPU, and you will be able to identify the error message. Now, this is one of the most important tricks that are there because on GPU sometimes error is not thrown, but on CPU it is. And finally, we using PDB is a great source for investigating the shape and type of variables. And here is a demo later to find that out. And Stack Overflow is your best source of information for later for all the errors that might happen. Now, I'm going to give you a short demo of PDB. As you can see here, the main purpose of this notebook, we will share this with you, is to read the traceback and how to read the traceback and also how to use PDB for interactive debugging. Most of the time when Python script fails, it will raise an exception. Now, when the interpreter hits one of these exceptions, information about this error can be found in the traceback and which can be accessed from here. Now, as you can see here is an example of a function wherein an exception is raised as division by is 0. Now, in Collab, we can expand the forms and see where exactly the error is happening as well, which is a neat trick here. And you can also edit this and go from there. Next, what you can see here is that instead of looking at the code and trying to figure out what happens there, this trace includes here a lot of several lines that can go to the next error. You can see which line specifically thrown the error with this arrow mark here, and also search Stack Overflow, the link which is given here. Now, let's look at an example of deep learning code and see how we can use PDB to investigate an error traceback. Now, you don't need to understand what this code is doing, but here, just to explain how the debugging you would have to do. Here, I run this particular code block and define my criterion and model output. And here I see that there is an error that is going here. The error message might here look complicated, but most of this error lines here that you see in terms of frames are involved in terms of the actual Python code, which you do not need to look into. We can assume that there is no bug introduced in the widely used libraries like PyTorch, NumPy, and so on. Hence, you just need to read the frames until right before it enters the frame. In this case, the most recent two frames. As you can see here, the error which is being called from here, the most recent one. So you can see that the error is here, which probably has to do something with the shape and format of the output and the target. To interpret the runtime error, the fastest way to click the Stack Overflow, as I already said. Now, I'm going to show you how the debugger is here. This debugger lets the PDB is used to identify common mistakes. So how here it works is that after you write an exception, the most convenient interface is the percentage debug command. After hitting an exception, it automatically opens an interactive debugging prompt at the point of the exception. Lets you explore the stack and the variables and even run the Python commands. Now let's look at an exception, which is the division by zero. Now when I look at percentage debug, I can see that this is where the error is happening. Now I can go for print A, printing A and B, and printing B. And you can see that this might be the cause of error. And then I press Q to exit it. And also you can also step up back through the stack to investigate what is happening using the up and then the down commands. Like here it goes back to that and then goes down. You can also press down to, and then similarly how you might do in Visual Studio Code to go back and forth. This allows you to quickly step through the entire code and find the error. Now, next, you can also, if you do not want to use the percentage debug each time, you can also launch the debugger automatically whenever an exception is raised. You can do this using the percentage PDB on function. So here, as I see here, you can see that there is an exception here that happens. And then here I can see that the debugger has opened again. And then if you want to continue to the next line, C works as a good example as well. Finally, if you want to monitor the behavior of your code, you can add a breakpoint using setTrace here, which essentially adds pdb.setTrace and add the breakpoint, and you can investigate the variable names and continue to the next time that is hit. So next time it is hit is when p is equal to 1, I mean I is equal to 1, and that's what is shown here. That concludes this recitation, and here are some of the commonly used PDB commands that you will find useful throughout this course. Thank you, and look forward to part 4.